All right, so let's talk about a classic web automation problem. Imagine you've built a script, right? And its job seems super simple. Log into a website and just grab a bunch of customer data. It's a task that gets automated all the time. But what happens when that website doesn't quite play by the rules?
I mean, on paper, the mission is a piece of cake. Step 1, log in. Step 2, go to the customer list. And step 3, copy all the data for every single customer. Sounds easy, right? Like a simple, straightforward task.
But this is where our simple little mission just hits a brick wall. The script gets to the customer list all ready to go, and it realizes this isn't just one page of data. Nope. It's up against an opponent that literally changes its size and shape every single day.
See, our script was probably designed for a nice, simple, static table, where all the data is on one page, everything's tidy. But what it actually found is something way trickier, a dynamic table. This is where the data is chopped up and spread across who knows how many pages. And worse, that number of pages can change at any time. So the script doesn't just have to read data, it has to actively navigate.
And when I say who knows how many pages, I am not kidding. The script loads the page and sees this number staring back at it. We're not talking about 5 or 10 pages here. It's got to figure out how to get through 11,909 of them. All of a sudden, our simple task has turned into an ultra-marathon. So this is the real million-dollar question, isn't it? How in the world can you program something to finish a race when the finish line might be in a completely different spot tomorrow? You can't just tell it, hey, stop after 11,909 pages, because next week that number could be totally different. This is the absolute core challenge of automating dynamic websites.
Okay, so to crack this, we can't just throw brute force at it. We need to be smarter. We need a real strategy, an adaptable battle plan that can handle this kind of chaos. And it really all boils down to 3 simple, logical steps. First things first, we need to discover the battlefield. Before the script does anything else, it has to find out the total number of pages it's dealing with right now. Step 2, advance page by page. It's going to march systematically from page 1 all the way to that final page it just found. And third, gather intelligence. On every single page it lands on, it will stop, read all the customer data, and then move on to the next one.
Now, the most important part of this whole plan, the absolute secret weapon, is that first step, finding that total page count dynamically. This one little piece of information is the key that unlocks the entire problem.
And this gets right to the heart of it. Like the source material says, you just can't hard code these values. That's a total recipe for failure. The second that number changes, your rigid script is going to break. It just won't work. The only way to win is to make the script smart enough to find the number all by itself, every single time it runs.
So how does it do that? Well, the website doesn't just give you a nice clean number. The script sees a whole line of text, kind of like this. The number we need is buried right there in the middle. The puzzle for our script becomes a bit like surgery. How to carefully extract just the digits 11909 and leave everything else behind. And the solution is actually pretty clever. The script is just programmed to find the location of the opening parentheses. Then it finds the location of the phrase pages. And the number it needs? Well, it's simply everything sitting in between those 2 points. It's a dynamic trick that's going to work whether the number has 4 digits or 6. Pretty cool, right? There's just one last tiny step. When the script grabs 1199, it sees it as text, like a word. It doesn't know it's a number it can count with. So we use a handy little programming method, something often called integer.parseInt, to do a quick conversion. It turns the text 1199 into the actual number 1199. And now, finally, our script has its finish line.
Okay, so the plan is ready. We've got our magic number. Let's actually see how the script puts this all together. It pulls off the mission using this really powerful concept called nested logic.
First, you've got what's called the outer loop. You can think of this as the master navigator. Its only job is to get from page 1 all the way up to our grand total of 11,909. For every page after the first, it just finds the right link, clicks it, and pauses for a moment for the new data to load. This is the engine that drives the whole operation forward.
But inside that page-turning loop, a whole second process kicks off. This is the inner loop. So while the outer loop is paused on a single page, let's say it's on page 42, this inner loop wakes up and gets to work. It counts the rows on that specific page, maybe there are 10, and it goes through them one by one, grabbing the customer name, then the email from each row. Only when it's finished with that page does it let the outer loop click over to page 43.
So you can really see how these two loops work perfectly together. The outer loop is the marathon runner, just focused on covering that massive distance, page after page. Meanwhile, the inner loop is the sprinter, doing these quick, intense bursts of work to grab all the data from the current page. The sprinter finishes its job, the marathoner takes one more step forward, and the whole process repeats itself thousands and thousands of times.
So there you have it. We've totally conquered the dynamic table. But the solution here teaches a lesson that is way bigger than this one problem. It actually points to a fundamental truth about how to create automation that's truly robust and, well, intelligent.
And this is it. This is the key takeaway. Successful automation isn't about writing a perfect, rigid list of instructions. It's about teaching a program how to observe its environment, find the information it needs, like a page count that always changes, and then adapt its own strategy based on what it finds.
And that really leaves us with a final thought. This whole observe and adapt logic solved our dynamic table problem. But think about it. What else could it handle? What about a pop-up ad that only shows up sometimes? Or a list of search results that has a different number of items every time you search? The same way of thinking is really the key to automating the entire unpredictable web.